All right, we're going to talk about the derivative, particularly finding the derivative of a function using the difference quotient. All right, let's begin. So what is a derivative of a function? Well, imagine you're riding a bike. And as you pedal your bike, you're moving forward, and you're going a certain speed. We have a function that tells us our distance is our rate times time. The derivative is basically telling us how quickly or slowly, what's the rate at which our distance is changing over time. Am I speeding up or am I slowing down? In mathematics, the derivative of a function tells us the behavior, the rate of change of a function at a fixed point. Now, the difference quotient. What is the difference quotient? The difference quotient helps us look at average rates of change for a function like our bicycle. If this is a function of my distance as I ride the bicycle, the difference quotient will tell me what my rate of change is between 2 points. Now, it has a special property that we start shrinking these points together so we can actually see what the rate of change is at one specific point. We get closer and closer to finding out the actual value at a specific point. So what does that look like using mathematics, like a mathematical equation? So we'll use f, this little apostrophe here means prime, so f prime of x, which is our derivative of our original function f of x, is the limit of this expression here, f of x plus h minus f of x divided by h, the limit of that as h approaches 0. What it means is, what is our rate of change for this function as h is the distance between these 2 points? It gets smaller and smaller and smaller, effectively becomes 0, at which point these are essentially at the same location, kind of, sort of. It uses the property of limits to find an instantaneous rate of change, the rate of change at 1 point. So let's see some examples and see how to do this. So our first example will be a linear equation. The function f of x equals 3x plus 2. Find f prime of x. So I need the limit of f of x plus h minus f of x divided by h as h approaches 0. We take x plus h and we replace x with that. This is how, just evaluating functions here. So this equals, I'm going to leave out the limit portion for now, 3 times x plus h plus 2 minus 3x plus 2 over h. We'll do the limit at the end, just to save space. So we use the distributive property here. Those are pretty simple algebra tools for us. Plus 2 minus 3x, distribute this negative inside, minus 2 over h. 3x and 3x go away. 2 and 2 go away, which leaves us with 3h over h. H divided by h, I can cancel h out, and so then I get the limit as h approaches 0 of 3. That's just 3. What it means is, and this should make sense, the rate of change is 3 for every single point on this function. No matter where I am, no matter what input I use, the slope, which is right there, this is in slope-intercept form, is 3. So we're verifying that using the difference quotient to find the derivative of a function does indeed give us the rate of change for the function at any point along that function. Let's see another example. Now I have g of x is our function, and it's a quadratic, x squared plus 2x plus 1. So I'm going to write out the quotient of the, and I always like to write the general form so that I don't forget to replace stuff. Ooh, pardon me, I'm going to sneeze. I was able to pause. Okay, so now we'll replace, this is going to go in there, and then this is just the whole thing. So equals, let's go x plus h squared plus 2 times x plus h plus 1 minus x squared plus 2x plus 1. Running out of room here. All over h. So remember, a mistake I see often is people rewriting this as x squared plus xh plus h squared. What is missing here? A 2. So when in doubt, write it out. Pardon my handwriting. And when you do that, you'll see you get x times h and x times h twice. So x squared plus 2xh plus h squared plus 2x plus 2h plus 1 minus x squared minus 2x. I'm distributing this negative in here. Minus 1 all over h. That is quite a bit. But the good news is we get to cancel some things out. 2x there, that goes away, this goes away. And all I'm left with is 2xh, h squared, and 2h. So let's rewrite that. 2xh in no particular order, except the order it appears. I can factor an h out of the numerator and the denominator, and I'm left with 2x plus h plus 2. And let me rewrite this, sorry. Yeah, so now I'm going to use an arrow here because now I want the limit of what's left, 2x plus h plus 2 as h, oh, sorry, we're not over h anymore. We already factored it out. As h goes to 0. Well, what happens is because this function is defined, this expression is defined at h equals 0, I can just replace all the h's with zeros, and what I'm left with is 2x plus 2 equals g prime of x. Now this is the slope. This is an equation for the slope, or the rate of change for any given point along this function. So if I wanted to find the rate of change at x equals 1, I plug a 1 inside here. So I use g prime of 1. So that's 2 times 1 plus 2, that equals 4. So the rate of change for my original function g of x at x equals 1 is 4. And we call that our instantaneous rate of change. Let's do one more example. So our last example, z of x is a function, and it equals the square root of x plus 1. So we want to know, what is z prime of x? Well, z prime of x is the limit, as h goes to 0, of z of x plus h minus z of x over h. So let's start replacing stuff. I'm going to leave this off until the end. We get square root of x plus h plus 1 minus square root of x plus 1 all over h. And we can't really do much here. We're going to do something we don't normally do, or we normally try to avoid, but we're going to put radicals in the denominator, so we rationalize the numerator. X plus h plus 1 plus radical x plus 1 over x plus h plus 1 plus radical x plus 1. Okay? The good news is, all we're left with is this minus this without the square roots. They cancel out. So I get x plus h plus 1 minus x minus 1. I also distributed the negative in through here. Skipped a step. Okay? And then denominator, I get h times parentheses, and I'm not going to do much with this here yet. Okay, I don't want to try to simplify this anymore because you'll see why in the next step I'm able to get rid of some things. So some things cancel out. X's go away, 1's go away, and I'm just left with h. Let's go to green. I get h over h times radical x plus h plus 1 plus radical x plus 1. These h's cancel, and I'm just left with a 1 in the numerator. So I have 1 over square root x plus h plus 1 plus radical x plus h. And now let's use the, so we find the limit. So z prime of x equals the limit, as h goes to 0, of 1 over square root x plus h plus 1 plus square root x plus 1. Now this function is defined, this function here is defined where h equals 0, so I can just use substitution. And what happens is this h just becomes a 0. So in the denominator, I have 2 x plus 1's under the radical, so I just get 2 times radical x plus 1. And that, not g, sorry, g was the last one. And that's z of x. So this gives me the, this is the equation for the slope at any point for our original function. So z prime of x gives me the rate of change for z of x, our original function. That's it for today. I hope this has been helpful. If you have any questions, you know how to get a hold of me.